Hey there, 5th grade. It's day 27 of NTI instruction. Today's Tuesday, April 27th, and this is our math video for today. Alright, so go ahead and turn to that page with me. So this lesson relates a lot to the lesson that we did yesterday. There's going to be some things that we did in that lesson with patterns that are going to be helpful when we are problem solving and finding rules for certain things. So our essential question here says, how can you use the strategy solve a simpler problem to help you solve a problem with patterns? Alright, so under unlock the problem, this is everything that we know, and then we're going to talk about solving those simpler problems and how that's going to help us get to the end result to answer our bigger problem, or our main problem. So it says, on an archaeological dig, Gabriel separates his dig site into 3 sections with areas of 15 square feet each. There are 3 archaeological members digging in every section. What is the area of the dig site if 21 members are digging at one time? So an archaeological dig, just for a little background, if some of us aren't sure what that means, that would be like digging up dinosaur bones and fossils and things like that. So that's what we're talking about in this scenario, or in this sort of story that we have here. Alright, so there's a lot of important information in here. So it says that he separates the site into sections that have areas of 15 square feet. That's really important. So, and you can kind of see here, it's really dark, but we're saying that this is 15 square feet, and this is 15 square feet, and that's 15 square feet, and that's 15 square feet. And then he could have more, but what it means is that only 3 archaeologists work in a section at a time. And so that's to make sure that they're not overlooking something or they're not too crowded, so that they can cover all of the area and not miss any of it. So 3 members in each section. So it says, what's the area of the dig site if 21 members are digging at one time? Well, so I know that each 15 square foot section is going to be for 3 people. So if I have 21 members digging, I need to figure out how many 15 square foot sections we're going to have. So, and to read the problem, what do I need to find? I need to find the area of a 21 person dig site. So what information do I need to use? I can use the area of each section, which is 15 square feet. And I know that there are 3 members in each section, and that there are 21 members total that are digging. So how am I going to use this information? It says, I will use the information to search for patterns to solve a blank problem. So a simpler problem. So we're going to use what we know to answer this simple problem to help us solve our more complex problem. Alright, so down here we've got a table. So these are our sections, and we know that our rule for the number of members is each time we have a section we add 3 members. So that's what's happening here. So for section 1, we have 3 members. If we have 2 sections, we have 6 members. If we have 3 sections, we have 9 members, all the way down to 21. Okay? So if we have 21 members digging, that means that we have 7 total sections. So for each section that we add, we're adding 15 square feet. So if we think about what that looks like, and really we can think about it like this, and think about those sections being these rectangles right here. So if this is 15 square feet, this one is 30, or these two would be 30, plus another would be 45, and we want to get to the end. So to be able to do that, we could look at the pattern between here, and I can see that the pattern is going to be add 15. Well, if I didn't know that, then I would have to figure out what's the pattern between my number of members and my area in square feet. That's how I can avoid writing all of this out and just figure out my pattern between the number of members and the area in square feet. So when I look at this, I'm going to multiply my number of sections. So that's right here. So I want to figure out what I have to do from my 1 to get to my 3. So I have to multiply 1 times 3 to get 3. So then I want to see if that pattern holds true for all the rest of it. So 2 times 3 is 6, 3 times 3 is 9, 4 times 3 is 12, yes. So I can say that my pattern here is to multiply the number of sections by 3 to get the area, or I'm sorry, to get the number of members, sorry. So that means if I have 7 sections, that's how I'm going to have 21 members. Alright, so now I want to see what's the pattern between my number of members and my area in square feet. So I'm going to say 3 times what is going to give me 15? Well, I know 3 times 5 is 15. So now I want to look and see, is that going to give me the same result when I go through here? So I'm just looking at my number of members right now, and I want to know if I multiply the top number by 5, am I going to get the bottom number? So 6 times 5 is 30, 9 times 5 is 45, 12 times 5 is 60, so it's working out for me, right? Okay, so what that means is that I can multiply 21 times 5 to get my number that's missing here. Or I can look at this another way, and I can say that I can multiply the number of sections times 15 to get the area. So, a few different ways to think about that. So, possible rules that we have are multiply the number of sections by 3 to find the number of members, or multiply the number of members by 5 to find the total area. So if we have the number of members as 21 and we multiply that by 5, then we're going to have our total area. So that's going to be 105 square feet if we have 21 members digging. Alright, On the back page, we're going to skip this page, and we're going to jump right into this one. Alright, at the top it says Max builds rail fences. For one style of fence, each section uses 3 vertical fence posts, so remember vertical goes up and down, and 6 horizontal rails. Horizontal goes left to right. How many posts and rails does he need for a fence that will be 9 sections long? Okay, so this is a section. This shows 2 sections. This shows 3 sections. Alright, so each section has 3 vertical posts and 6 horizontal rails. Oh, I see. I was thinking they went all the way across, but there's one here to here, here to here, here to here, and then from here to here. Yeah, okay, so that's where we get 6 from. I got it. So it says, first, think about what the problem is asking and what you know. So this is kind of a complicated question just to read and not really know what's going on, because you've got to kind of plan it out, which is what we're doing here. So the biggest thing that I want you to get from this today is how to plan out a problem. We're breaking it down into something simpler so that we can figure out something more complex. Alright. As each section of fence is added, how does the number of posts and the number of rails change? Next, make a table and look for a pattern. Use what you know about 1, 2, and 3 sections. So 1, 2, 3 sections, and we can see those up here. And then it's listed in our table right here too. And write a rule for the number of posts and rails needed for 9 sections of fence. So we go from 3 all the way to 9, which means if we can figure out this pattern, we don't have to know about 4 sections, 5 sections, 6 sections, 7 sections, 8 sections, and then to get to 9 sections. That's why we're using this simpler problem to solve this one. Alright. So, if we're talking about the number of sections and the number of posts and the number of rails, then we want to see sort of what patterns do we notice here. So, I see a lot of 3s. I feel like there's a lot of multiplying by 3 on this one. So, it looks like the number of section times 3 is going to give us the number of posts. So 2 times 3 is 6. 3 times 3 is 9. So that means that I should be able to multiply 9 times 3 to get the number of posts, which would be 27. So then I want to see what kind of I was reading this word post over here, and I want to see what kind of pattern I have between 3 and 6. So when I have my number of posts, it looks like I have to multiply by 2 to get the number of rails. So let's see if that's true for each one. So 3 times 2 is 6, 6 times 2 is 12, 9 times 2 is 18. So that means I need to multiply 27 times 2 to get my number of rails for 9 sections. So 27 times 2, let's see, that's 54. So 54 rails. So now we have to write what our rule is. We solved our problem, so we have to see what is our possible rule for the posts. So we could say multiply the number of sections by 3 to get number of posts. And then our rule for our rails is multiply number of posts by 2 to get number of rails. And then our last step is to solve, but we solved while we were talking through it. Alright. So number 2 says, what if another style of rail fencing has 6 rails between each pair of posts? How many rails are needed for 9 sections of this fence? Okay. So now we've got the same pattern with our post, but now we're going to pay attention between our posts and our rails. So I notice that from 3 to 12, well, how do I get from 3 to 12 with multiplication? I have to multiply 3 times, let's see, 3, 6, 9, 12. So I have to multiply by 4. So now I want to see, is it going to be the same pattern? So I should be able to multiply 6 times 4 to get, yep, 24. 9 times 4 is 36. So, how am I going to get my number of posts? Well, I got it up here. It was the same, right? My number of posts didn't change. How did I get it? I multiplied my number by 3. So 1 times 3 was 3, 2 times 3 is 6, 3 times 3 is 9, 9 times 3 is 27 posts. So now I'm going to multiply 27 times 4 to get my number of rails. So my possible rule is multiply number of posts by 4 to get number of rails. So 27 times 4 is 108. Alright. Number 3. Leslie is buying a coat on layaway for $135. She will pay $15 each week until the coat is paid for. How much will she have left to pay after 8 weeks? So how much is she still going to have to pay? And I am going to leave this with you as a challenge question. Text me, email me, call me, dojo message me with the answer, and if you are correct, then I will send you a surprise in the mail. Those people that won surprises from me last week, that was Honeycutt and Asharia and Brooklyn. I am putting those in the mail to you tomorrow. So I'll give you until, let's see, let's say Thursday morning at 10 o'clock. Thursday morning at 10 o'clock is going to be our cutoff. So if you get this answer to me between now and Thursday morning at 10 o'clock and you're correct, then I am mailing you a surprise either Thursday or Friday, depending on when I can get those ready. Alright, so that's your challenge for today. Alright. We're going to skip this page and we're going to go to this page. Alright, so number 1 is done for you. You're going to read what you got here. You're going to figure out the rule. and fill in the missing numbers. So think about what's the pattern between the top number and the bottom number. How do I get from this number to this number? And it's always going to be a multiplication pattern on these. So your possible rule is always going to be multiply something. So this is also going to be a multiplication rule. Alright, on the back you've got some review questions here. So that is the end for today. Remember your challenge, question number 3. That's on page 393 on day 27. So get that to me by Thursday morning at 10. Call, text, email, dojo message, something. Don't post it publicly because I want to give everybody a chance to answer that. So send me your answers secretly, and I'll put my number on here again if you need it. Text is the easiest way to get me, or email me. Alright, so there's my information. Get that answer to me if you're correct by Thursday at 10 o'clock in the morning. Then I have a surprise ready for you. Talk to you tomorrow. Bye.